Welcome to chapter 16. In this chapter, we'll study permutations and combinations. This topic is frequently tested in LCAT, and today we'll start with the fundamental counting principle, which is the base for all of the problems we discuss in this chapter. If an event can occur in M ways, and another independent event B can occur in N ways, then the total number of outcomes M multiplies with N, and always multiply the independent choice. For example, here for two options, and hence two more options. Therefore, number of culprits are 4. Let's extend it to multiple events. In case of 3 events, it will just be the number of choices in the first times the number of choices in the second times the number of choices in the third event. For example, and 3 types of breads. Similarly, lunch, mains, and desserts. In this case, first of all, we need to find the number of choices for each uh, meal, for breakfast separately and for lunch separately. After that, we can calculate their total outcomes. For example, for breakfast, it would be 2 times 3 because there are 2 juices and 3 breads. Similarly, for lunch, 3 mains and 2 desserts. And hence the total meals is equals to the number of meals in breakfast versus times the number of pills and lunch. Similarly, if we have more events, for example, 4 events, we'll multiply it with the number of choices of 4 events, and hence the n events can be continued for n entries. Now let's discuss the factorial notation. N times n minus 1 times n minus 2 until we reach 1. For example, now in order to save your time during LUMS, you can ignore the 1 since multiplication with 1 yields the same result. Therefore, you can just remove the 1 from the formula and just stop at 2 as well. Therefore, that's it. This is stop at 2. There is one important thing about factorial, that is 0 factorial, which is always equals to 1. So please note that if you ever, you know, have 0 factorial in the answer, don't get confused. It's just equal to 1. Let's do a simple example. Now, in this case, we have 3 digits. Therefore, we'll have 3 independent events. The first digit has no relation with the second digit, so on for the third. So how many choices do we have for the first digit? In our case, we are given 3 numbers, 1, 2, and 3, and therefore we'll have 3 choices. For the second digit, we again have 3 choices, and for the third digits, we again have 3 choices because the repetition is allowed here. We'll discuss this in detail in the next part as well. And therefore, the total outcomes would be 81.